Hey everyone, Mr. Fransky here. This is definitely an optional proof, optional video to watch. It's going to be deriving the equation of an ellipse. Remember the equation of ellipse, x squared over a squared plus y squared over b squared equals 1. And I just kind of gave this to you in the intro to the Ellipse video, and I said, you just have to assume, take on faith that this works, but I said I would prove it in another video, so here we are. So this, like I said, is definitely a proof hat proof. This is not something that you'll be asked to replicate, but it's kind of some interesting algebra, and it's just really expanding and factoring and using the distance formula. It's not really that hard, but we're just going to derive the equation for an ellipse in here. So foci, major minus axis, and the distance formula are kind of going to be the key things to finding this thing. So first of all, this is the same slide we had in the intro video. The definition of an ellipse is the set of all points in the plane whose distances from two fixed points have a constant sum. So that means d1 plus d2 is always going to be some constant. We can call it c, I guess. It's some constant sum. And we're actually going to figure out what that is in this video. But that means no matter where x is, no matter what xy is, if you add those two distances together, they're always going to equal the same thing. Okay, so that's the first thing we're going to kind of focus on. We need two important things that we're going to keep in our pocket for this proof. You could call these lemmas. Lemmas are things that you have to prove quickly that you're going to use later in your proof. So the first thing I'm going to do is I'm going to use the coordinates at one of the vertices. This is A0. So this has to follow the rules of every other point on the ellipse, right? We said any point on the ellipse, if you draw two distances in, the sum of those distances always has to be the same. So I'm going to use this point to figure out what that distance actually is. Remember, this distance right here is c. This distance here is also c. Okay, and this entire distance from here out to the edge is a. So if I take the distance from the first focus point out to this point at a0, that distance is going to be c here plus a here. Okay, so let's call that d1. Okay, so d1 is c plus a. And then the distance from the second focus point is going to be from here to here. Let's call that d2. So d2 is going to be, let's see, well, it would be a minus c, right? This length right here would be a, but you don't want the c part there. Okay, so that's going to be a minus c. So we said d1 plus d2 always has to be the same thing. So if you add these together, you have 2a and the c's cancel. It's just 2a. So what that tells us is that any point you pick on here, if you add d1 plus d2, it's always going to be 2a. Always, always, always. So that distance is, that constant distance is always 2a. So d1 plus d2 is always equal to 2a. Okay, so that's the first thing that we're going to use. And now the second thing, we're going to use the point at the top here. Okay, this coordinates there are 0, comma b. And if we take our triangle that we make here, that's an isosceles triangle, right? These distances are the same because this is positive c and negative c. So you have c out to the right, c out to the left. This is the hypotenuse of a right triangle on both sides. It's the same on both sides. So because we know that d1 and d2 are the same here, and the whole thing is 2a, that means they both must have a distance of a, or a length of a. And that's because if the whole length is 2a, then if you split it into two parts that are equal, they each have to have a distance of a. I always thought that was cool. That means if you take this rod right here and you just kind of tilt it up, it's going to have that same length. It's kind of cool. So now what we're going to do, we know this is c, this is b, and this is a, and we can make a relationship between a, b, and c. B squared plus c squared equals a squared. This is where c squared equals a squared minus b squared comes from. Right? That was one of the things that we kind of took on faith when we first learned, right? We had that was a relationship between A, B, and C to be able to figure out where your focus points are. And in this case, actually, what's going to be more useful is that B squared is A squared minus C squared. Okay, so we're going to put this in our pocket, put this in our pocket. Those are two things we're going to use in the proof for proving this equation. All right, so now the distance formula is going to get us started. So I'm going to write those down over here. So we know d1 plus d2 is equal to 2a. And we know that b squared is equal to, was it a squared minus c squared, c squared minus a squared? A squared minus c squared. Okay. So, distance formula. So we know d1 plus d2 is always going to be equal to 2a. So let's actually find d1 and d2. So the coordinates of this focus point right here are c0, and this guy right here are negative c0. So use the distance formula to add those together and set them equal to 2a. So the distance from here to here is going to be the square root of x minus negative c, so x plus c squared, plus y minus 0 squared, plus, so the square root of this guy, so we had to do distance formula on this point, the square root of x minus c squared plus y minus 0 squared. And we add those two distances together, it always has to be the same thing, and we proved that that's equal to 2a. Okay. So what I'm going to do now is I'm going to move this guy to the other side. Get rid of that. Okay, so move this guy to the other side, and I'm going to clean these up a little bit. Okay, so we have the square root of x plus c squared plus y squared is equal to 2a minus the square root of x minus c squared plus y squared. Now what we're going to do is we're going to square both sides. On the left side, that's nice. The square of the left, if we square the left side, the square root will just go away. And I'm actually going to expand this at the same time. So I have x squared plus 2cx plus c squared, right? That's the expansion of x plus c squared plus y squared is equal to. Now when we square this side, we have to do it like a binomial. You kind of have to FOIL it, right? So we'll have 4a squared. That's 2a squared. And then minus 2 times the first thing times the second thing. That would be 4a times the square root of x minus c squared plus y squared. And then plus the second thing squared. So the square root will go away, and once again, I'm going to expand stuff out. So you have x squared minus 2cx plus y squared, plus c squared, and then plus y squared. Okay, now some stuff goes away. The x squared cancels. What else goes away? The c squared cancels. The y squared cancels. I think that's it, though. Okay. So let's clean this up a little bit. Let's see. We got 2cx is equal to 4a squared minus 4a times the square root of x minus c squared plus y squared minus 2cx. So what I'm going to do now is I'm going to get that root isolated. So I'm going to keep that root on one side, and I'm going to move everything else to the other side. So I'm actually going to add the root, and I'll move everything to the right. So I have 4a square root of x minus c squared plus y squared is equal to, so now everything else on the right side. So 4a squared minus 2cx minus, another 2cx is minus 4cx. Now, they all share something in common I want to get rid of. Let's just divide everything by 4. That just gets rid of all these. That's nice. Now what we're going to do is we're going to square both sides again. Okay, so we're going to square this side, and we're going to square this side. Left side, we have a squared times, I'm going to expand this out. Let's use bracket. So let's see, we're going to have, so the square root takes the square root away, but I'm going to expand this out. So we have x squared minus 2cx plus c squared plus y squared equal to, if we square this side, we'll have a to the 4th minus 2 times a squared times cx plus c squared x squared. All right, see if we can fit one more step on here. So now I'm going to distribute the a squared and see if anything cancels out this time. So let's see, we're going to have a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared equal to a to the 4th minus 2a squared cx plus c squared x squared. Looks like the a squared cx's go away, right? If we add it to both sides, it would go away. That's a square. Okay, so now I'm going to take this, I'm going to go to the next slide. We'll see if I can get everything. So we have a squared x squared plus a squared c squared. I think I'm going to have to do it in a few steps here. So we had a squared x squared is plus a squared c squared plus a squared y squared. So a squared x squared, a squared c squared, a squared y squared is equal to a to the 4th plus c squared x squared. Now, we're going to move some things around to make it factor an exact way that I want it to factor. So what I'm going to do here is I'm going to leave the a squared x squared on this side. And then I'm going to subtract the c squared x squared from that side. Really what I'm doing here is I'm gathering all the x's on one side and the constants on the other. But I'm going to keep the a squared, so the x's and the y's on one side, the constants on the other is what I'm doing. So c squared x squared, and then plus a squared y squared. So I'm going to keep that much on the left. And on the right side, I'm going to have then a to the 4th minus a squared c squared. The reason I do this is because, remember, our goal is x squared over a squared y squared over b squared equals 1. So I want all the constants on one side and the x's and y's on the other. Now we're going to factor out what we can. So out of this side, I'm just going to factor out an x squared. So I have a squared minus c squared times x squared. So I should pull an x squared out. I put it on the right side. You might be used to putting it on the left side, but it doesn't matter where you put it. Plus a squared y squared. Uh-oh. What did I just do? There we go. So plus a squared y squared is equal to, now over here I can take out an a squared, times, what would be a squared minus c squared. Okay, so this a squared minus c squared is showing up twice. That's interesting. Now, we're going to use the second thing that we wrote down here. A squared minus c squared is b squared. So I'm going to put that in where this a squared minus c squared is. So I have b squared x squared plus a squared y squared equals a squared b squared. Now we want a 1 on the right side, so I'm going to divide both sides by a squared b squared. Right side is 1. Left side, you lose the b squared from this, so I have x squared over a squared. Here we lose the a squared, so you have y squared over b squared. And there is our equation. Oh, lots of fun algebra. Look at all that. Oh boy, that's fun. Okay, but it ends up working out, which is kind of cool. And it ends up being a really pretty elegant equation that's really easy to use and really easy to graph. So I hope you enjoyed watching this. I hope that you are, if you made it to the end of this video, you're probably pretty curious about math, and I really appreciate it. So you know that I have a great passion for math, and I hope that I can ignite some of that in you too. All right, love you guys. That's why I'm here. Have a great day. I'll see you in a future video.